Chapter 6. Discrete probability distributions. A random variable can take on values that are either discrete or continuous. This chapter has focused on discrete random variables where the potential values are usually integer values. Examples of discrete random variables include the number of defects in a sample of 20 parts, the number of customers who purchase Coca-Cola rather than Pepsi when 100 customers are observed, the number of days late a shipment will be when the product is shipped from India to the United States, or the number of female managers who are promoted from a pool of 30 females and 60 males at a Fortune 500 company. The probabilities associated with the individual values of a random variable form the probability distribution. The most frequently used discrete probability distributions are the binomial distribution and the Poisson distribution. Introduction to discrete probability distributions. A discrete random variable can assume only a finite number of values or an infinite sequence of values such as 0, 1, 2. The mean of a discrete random variable is called the expected value and represents the long-run average value for the random variable. The graph of a discrete random variable looks like a histogram with the values of the random variable presented on the horizontal axis and the bars above the values having heights corresponding to the probability of the outcome occurring. The sum of the individual probabilities sum to 1. The binomial probability distribution. The binomial distribution applies when an experimental trial has only two possible outcomes called success and failure. The probability of success remains constant from trial to trial. The trials are independent, and there are a fixed number of identical trials being considered. The probabilities for a binomial distribution can be calculated using the equation derived from the binomial table in the appendix, or found using Excel or Minitab. The expected value of the binomial distribution is found by multiplying n, the number of trials, by p, the probability of a success on any one trial. The shape of a binomial distribution depends on the sample size, number of trials, and p, the probability of a success. When p is close to 0.50, the binomial distribution will be fairly symmetric and bell-shaped. Even when p is near 0 or 1, if n, the sample size, is large, the binomial distribution will still be fairly symmetric and bell-shaped. In this section, you need to be able to calculate and interpret the expected value of a discrete random variable. Other discrete probability distributions. Although the binomial distribution may be the most often applied discrete distribution for business decision makers, the Poisson distribution and the hypergeometric distribution are also frequently employed. The Poisson distribution is used in situations where the value of the random variable is found by counting the number of occurrences within a defined segment of time or space. If you know the mean number of occurrences per segment, you can use the Poisson formula, the Poisson tables in the appendix, or software such as Excel or Minitab to find the probability of any specific number of occurrences within the segment. The Poisson distribution is often used to describe the number of customers who arrive at a service facility in a specific amount of time. The hypergeometric distribution is used in situations where the sample size is large relative to the size of the population and the sampling is done without replacement. Conclusion. Business applications involving discrete random variables are very common in business situations. The probabilities for each possible outcome of the discrete random variable form the discrete probability distribution. The expected value of a discrete probability distribution is the mean and represents the long-run average value of the random variable. Chapter 6 has introduced 3 specific discrete random variables that are frequently used in business situations: binomial distribution, Poisson distribution, and the